Okay, so hello everyone, and welcome to the Scale Solution webinar with South32. Excited to get this underway today. I know we've had lots of questions in the forum to date, and hopefully this provides a forum for you to chat directly with the site team. We've got a number of the site team here on the line today, who'll be able to answer any questions directly, and anything that they can't answer, we can pen and respond to over time. Before we start, if we could just make sure that we're on mute, I will open up for direct questions later on and ask people to come off mute when a slot is available. If you have any questions as we're moving through the information up front, please feel free to drop them in the chat and I can narrate and share them with the team as the Q&A starts. Before we start, I'd like to just make an acknowledgement of country and say that we acknowledge and pay our respects to the Indigenous, traditional and tribal peoples of the lands, waters and territories on which South32 is located and where we conduct our business around the world. We respect and acknowledge the unique cultural and spiritual relationships that Indigenous, traditional and tribal people have to the land, waters and territories and their rich contribution to society. In the spirit of respect and reconciliation, we will continue to support initiatives that strengthen cultural and ways of life so that their legacy continues and extends to future generations. Okay, guys, so just a quick overview here before we start moving through in a little bit more detail. Just a quick overview of what we're going to move through. So these are the segments today, and ultimately we're going to move towards a Q&A session at the end. We're going to have the team speak to points number 2 and 3, so you can hear directly from the site team around the background of the problem statement and directly around the challenge and the challenge that they face at the Worsley refinery. I'll be coming in and out as we go and providing a little bit more context around the opportunity, how you can engage, etc. So first off, before I hand over to Ashley and the team on site, just a quick introduction to the team who are on the line here today. We've got Ash Royston, Manager Technical, Darren Hope, who we've been working really closely with on our weekly check-ins with site, who is Engineering Senior Process, Daryl Wilson, Principal Technology, Brenton Rowe, Superintendent Maintenance A&I, and Jamie Oakey, Specialist Work Management Planner. So great capability from the operations on the line today. Just as a another reminder, if you do have any questions, please either ask them in the Q&A session or drop them in the chat as we move forward. At this point, I'm happy to hand over to Ash or the team here to take us through the next steps and introduce the background to the challenge and the problem statement.
Cool. Thanks, Jake. Yeah, Ash Royston. Also in the room is Mark Graham, who's our Bayer Maintenance Manager for today's session. Yeah, so background here. So at Worsley, we're really interested around innovative work methods for preventing, monitoring and predicting and safely remediating the various scale that we can get in the refinery systems in the processing equipment. So what do we mean by scale? So scale refers to the build-up of minerals that basically will occur over time within our processing equipment, in different parts of our processing equipment. That's often in pipes, tanks, vessels at the refinery. If we don't address that adequately through different means, we can build up in local areas and severely restrict the operation of process equipment. So how this plays out, it can be around efficiencies. It can impact us through efficiencies. It can impact us through throughput. It can impact our predictability and reliability of equipment and the associated operating and maintenance strategies required. So with that, I might just hand over to the team that have been working through the challenge around further introducing the Scale Solutions Challenge at Worsley.
Okay, put the next page there, Jake, if that's all right. Yeah, so I'll move it so I can actually see me while I talk. So look, the challenge that we're really interested in, we're looking at essentially 4 different things. One, how do we prevent the scale from building up? How do we monitor how the scale is building. So how's it growing within our equipment? How do we predict it better? We have some prediction methods, but we're always looking for better opportunities. And how do we remediate, or how do we remove the scale from our system? They're the four types of opportunities that we've seen coming into this challenge as well. What can we do better? And that's ultimately where we sit. So the types of scale that we typically get: gibbsite and bomite, which are basically alumina-based scales, and also the formation of calcium and also silicate. So we call it DSP scales within our facility as well.
It's probably worth talking just quickly on the so Ash has highlighted probably some of the impacts from from a processing perspective and things like that, but we also invest a huge amount of resource in managing the impact of scale within the refinery to make sure that we can mitigate some of those things that Ash pointed out. So we put a huge amount of resource, and has a significant impact on the availability and we call it the operating factor, but basically the available uptime for our equipment. So we've got very large teams of people who spend working full time and a large equipment base to deal with scale across the various areas of the refinery as well.
I might just touch quickly on the chemistry. We've probably got a couple of chemists on the call, but look, it won't come as a surprise to most people. The scales form because the system is super saturated with respect to those phases. So in the Bayer refinery, we go from undersaturation in digestion to supersaturation post-digestion, where we want to precipitate out the gibbsite, the desired phase is our product, but we're supersaturated with respect to multiple phases. So that's where we talk about alumina scales, calcium scales, silica scales, and that's not the end of the list, if you like. A lot of the scales are multiple phase, and at the moment, our cleaning processes are really chemical. So that is an unsaturated hot caustic, or it's an acid. So it's basically just a dissolution with an acid. Or it's a mechanical clean. So a lot of our scales don't respond well to chemical cleaning. So mechanical cleaning that Mark talked about, that's also a big part of how we get rid of this stuff at the moment. So the size of the prize is pretty big here for us around that.
I mean, mechanical cleaning, a lot of water jetting on site where your caustic or acid cleaning doesn't give us the results we're after. So it's a lot of work, and where we have large amount of scale build up beyond what we're expecting or predicting, the turnaround amount of activity by particularly like Mark's team to turn around equipment through different methods to clean the material out and then maintain the equipment can take a lot longer than expected, and a lot more work by all those teams. So it's really around getting that predictability.
Okay. Great, thank you for that insight there and background. I'll just move forward through the next few slides, and then we'll open up the Q&A. So with the opportunity within this challenge is being delivered in collaboration with South32, the innovation team who we work directly with, as well as the operational team at Worsley. For those who proceed through the challenge and are selected after challenge close, there's the potential to drive forward through studies, testing, engineering, field trials, and potential commercial agreements moving forward. And the overall, I guess, prize, we often get asked around prizes at Unearthed, is to potentially win South32 and the Worsley team as a customer moving forward. Just to talk about timelines for the challenge as it is now, it's obviously open and in the market. We've had a number of early submissions come through, which are great, and had a number of detailed discussions as well with various groups, some of whom will be on the line. These are open until early December, and then we will, I believe, we'll be conducting an on-site review session with the team, both from Unearthed and South32, to fast track the review process, and then we will inform innovator groups if they are to proceed forward in the process in probably mid to late January. If you want to make a submission or learn more or look at the forum, you can jump onto our website. There are various other challenges on there at the moment, but Scale Solutions is very much live and willing to be engaged with. We've got a number of early submissions, as I said. If there's any issues at all around engaging within the platform, logging in, etc., please reach out to myself or the wider team at Unearthed, and we can help facilitate that. If you do have any questions that are missed today, don't get time to get to, have another question after the event. If you look on the far right-hand side, there is a forum, and we've received, I think, 3 questions now to date, which have been quite technical. We will work with the team on site to respond to those as quickly as possible. So we're always grateful for your time in delivering these submissions. Realistically, it's going to be 9 questions. And if you've got any available marketing decks or similar to showcase your capability, probably I generally will advise between 90 minutes to 2 hours to complete those, possibly slightly more if you don't have decks, etc., available. We can now open the Q&A session. If anyone is interested in posting directly into the chat, please let me know and I can share those with the team. Is there anyone that's interested and willing to come off mute? And I'm happy to open the floor. If not, we do have some questions here surrounding that we've received via email ahead of the session.
Hi, everyone. Can you hear me?
Yeah, go ahead, Brad.
Yes. Hi, everyone. Yeah, Brad Walsh from Enviro Systems. A couple of questions. One, is the piping material that you use, is it ferromagnetic? Like, something with a magnetic mount would stick to it?
Yes, correct.
Awesome.
Yep.
All right. Thank you. And then the second question is, for the sections of piping that are prone to scale buildup, are they accessible externally by a person?
When you say accessible, I suppose
Lots is not.
Yeah, so a lot of our pipe work's quite elevated up in pipe racks and things like that. So it's accessible in terms of, you can potentially get to it with elevated work platforms. Like in some instances, we'll build scaffold to it to access certain piping streams and things like that. So yeah, and some of our pipe work is also lagged as well. So that's probably the third part. But there is a percentage of our pipe work. So scale forms in a lot of our piping systems. So a large percentage of our piping systems would not necessarily be cladded, and we would have access externally to them.
Yeah, okay, sure. Yeah, just for context, what we're thinking as an application is to fit something like external to the pipe that can measure potentially the scale buildup, but obviously you need access to that external pipe section to fit it.
Yep.
But once it's fitted, it'll be all remote, battery powered or hardwired, etc.
Yeah, okay. Yeah, no, we can definitely, so we can access, for installation and removal and things like that. So yeah, we do that on a routine basis for both maintenance purposes as well as inspections and other things. So
all right, thank you. That's everything from me.
Yep. Thanks, Brad.
And would anyone else like to jump in?
Yeah, I'd love to, Jake.
Go ahead.
Hey guys, Corey Pritchard from Predict. Just a question on the current methods of detecting these things and the way you say you do the maintenance. So what's the strategy right now? Is it a time-based thing? Is it a performance on some things thing, or like what's the overall?
Yeah, so there's different strategies depending on the application. So if we're talking pipes, tanks, vessels, many of those, just based on historical data, are time-based for when those will go on cycle, particularly vessels and tanks. The piping associated with that, most systems will be inspected when it comes offline with the relevant tank and vessel. So typically they are time-based, but there are other things which will pick up, which will tell us condition-based that we need to change relative to the current strategy. So whether that's restrictions, which tell us we've got pressure drops across systems, or let's say if it was tanks, the tank's rake's working harder than it should be for a particular campaign, then we may pivot and change. But yeah, so and typically there's a a system which is able to be offline while there's online systems, so you can inspect that system while it's offline for that cycle, and then measure the scale and measure what's in there, which caused the equipment to come off, or what it measured from a planned period online.
Yeah, and then I'm guessing you try and return that back into the next cycle in some way and try and learn something from the build-up scale and kind of what characteristics cause that and those types of things.
Yeah, absolutely. So we'll typically grab, if it looks unusual, we'll grab samples to confirm the composition. We'll have different measurement systems around build-up, and I might leverage into some of the other team members here for those inspections. But for pipe work, we've got ways of doing internal inspections of pipe work, as well as inside tanks using different technologies. Might throw the marking team around some of the things that we do there for inspections and data collecting.
Yeah. Just lastly, has there been any studies kind of, you said about some performance things, but any kind of like looking at more than a couple different sensors at once, looking at kind of, system or subsystem level, like performance, modeling what the whole system's doing, and then trying to see if those can find some changes that correlate to build up in a like, larger modeling way, and not just, a couple process variables?
Yes. So happy to take this if anyone else doesn't want to lean into it, but it's heat transfer is a normal one. So we'll look for performance around heat transfer. We'll look for performance around flowability in there, and also chemistry side of things. So we have measures where we're measuring liquor chemistry around site. We're looking for changes in that chemistry, and we can, I guess, generally pick up if something might be depositing as a result of some of those changes. But they're some of the main ones. There's also things like external thermal imaging we do to see if we get build up on certain bits of equipment. I'm not sure if there's any other condition monitoring we want to call out that are for scale build up while we're online we want to talk about here.
No.
No, cool. Yeah, cheers for the insight.
Thanks, Corey.
Thanks, Corey.
I might just jump in here and ask a few of the questions that have come through in the chat. So James has asked, what abrasives particle material do you use currently, and how much do they cost?
For cleaning, is that what you're talking about?
I will read through and I will say yes. Yeah.
Yes, for cleaning, and also interested in disposal. How do you dispose of it post-use? Thank you.
Thanks, James.
Yeah, so most of our cleaning, we use high pressure water blasting or water jetting is our primary means of removal. So we don't necessarily have an abrasive medium that's associated with that. So yeah, we do abrasive blasting on site, but it's more for infrequent use around certain sort of niche activities such as vessel integrity or tank integrity inspections and things like that. Occasional paint blasting type activities, but relatively lower volumes and a very small subset, I suppose, of our overall cleaning activities. As I say, most of our resourcing goes into high pressure water blasting. Does that answer your question, James?
Yes, it does. Thank you. And the abrasives that you do use on site for those tanks and inspections, what do you do with them after you?
I'm not sure we actually collect it afterwards, do we?
I think we use we do vacuum. So when we've done them for a particular tank vessel inspection type activity, we'll get a vac truck in and basically collect all that out. Where it goes past that point in time, to be honest with you, I'm not exactly sure. So
We dumped.
Yeah, landfill.
Dumped
Out of the
landfill.
On-site landfill.
Okay. Thanks for that, James. I'll just move through in order. So Will has asked, how often do you take the plant offline for scale build-up removal?
So through most of our sort of process streams, there's always, so we've typically got sort of N-1 redundancy. So we've always got a level of a redundant stream, if you like. So that stream is typically under maintenance and cleaning activities, and that happens through the various parts of the process. So typically we've got a section of the plant off, with that working through that cleaning process, and then basically, and everything works, to Ash's point earlier, everything works on cycles, generally speaking, for our major equipment. Obviously, to get access to things, we need to have sort of predictable campaigns so we can use that, that redundancy effectively and not have, multiple streams offline at the same time and things like that. So, a lot of it is driven by time-based strategies, as we spoke about earlier.
But the general flow in the plant operates 24 hours a day, 7 days a week.
Okay, brilliant. Thank you. Peter has asked, do you have any experience with application of lining materials to prevent the scale buildup?
Do you want this one, Daryl, or me?
The short answer is not a lot, if you like. So, look, it's one that over the years we've considered. It's come and gone, if you like. We don't have any live applications now, at least I'm aware of, for preventing scale growth. Look, it's something we'd entertain. Any kind of lining would need to meet a few criteria. So obviously it's hot caustic as our process stream, so it's going to be pretty tough and resilient. It's going to need in a lot of applications to have a high abrasion resistance as well. We're pumping slurries through most systems, not all, but a lot. Largely chemically inert, not prone to delamination and those sorts of things. So, and cost effective as well. So, I guess all of the applications or potential solutions we're talking about today, that's at the back of it. I guess all of those need to remain cost effective.
Okay, great. Is there anyone in the room that would like to come in now, ask a question? I'll open it up if anyone wants to come in. I thought I saw Michael come in there. If anyone wants to jump in, if not, I'll continue through the stream. No? Okay. Nada has asked, what is the minimum size, e.g. thickness in millimeters, of buildup that would be required to be detected for a useful solution in tanks and in pipes?
It's a good question. It depends on the application. So we're probably dancing around it a little bit, but depending on where it is, the scale build out will have different impacts depending on the location. So yeah, for pipes, we'd probably notice those restrictions a bit sooner. Heat exchangers probably even sooner than that. Whereas tanks and all vessels is probably could be a little bit higher before we notice the impacts. So probably been dancing around it a little bit, but it depends on the duty of application. So I'd say the heat exchangers and pipes. Heat exchangers would be where we're most vulnerable to feeling it.
Yep.
Probably then pipes, tanks and vessels.
Yeah, so like a plate heater, if we're talking millimeters.
Yep.
And and from a millimeter to a couple, because obviously plate heated plates are very close. Yep. Shell and tube, same deal. It's be millimeters in tube scale. But like Ash said, in pipes, you're talking centimeters.
Yep.
Of that order. And tanks, it's potentially tens of centimeters.
Great, thank you. Bimlan has asked, what initiatives have been undertaken to reduce the rate of scaling deposition to date?
Yes, so happy to lean into it, but we always actively are reviewing our chemistry profile. One for stable operations and what we're here to do, which is safely make alumina. The part of that is we need our chemistry to be productive to be able to make alumina as per our goals. So part of that is we are actually deliberately trying to precipitate, and where that's you want that to occur from a good perspective, I guess, is in precipitation. So we're always actively watching our chemistry profile to make sure we precipitate in the locations it's supposed to, and like Daryl said, we do supersaturate the liquid to do that. So we're constantly monitoring our chemistry profile. We're also constantly monitoring our impurity profile in the liquor going around the refinery. So our bulk side has a number of trace impurities in it, and the build-up of those different impurities over time in our liquor, if we don't adequately remove them, can deposit as scale in different locations depending on the duty and the chemistry there. So nuts and bolts, we actively monitor and sample our liquor chemistry. We have a control laboratory on site, and we do that with daily and weekly samples.
Probably the other thing that we do is we do a lot of drone inspections inside tanks and vessels, and we use that information to feed forward into optimizing our campaign durations of certain pieces of equipment, and manage the risk. And every equipment group is a little bit unique in that regard, but we're always endeavouring to sort of optimize the campaign life in between cycles. So
was there anything further from a chemistry side we wanted to call out at all just for that question?
I don't think so. I think it's mainly around just knowing that all our streams are typically super saturated, and it's just trying to get the scale to come out in the right areas rather than the wrong areas. But I think you covered it pretty well though, Ash.
Yeah, maybe another point worth mentioning, refinery's been running for 40 years, and that experience is a good teacher, if you like. We've learned in that time how to manage a lot of things. It's taught us about timing, outage frequencies and maintenance strategies and everything else. So a lot of our management of scale, if you like, is simply around what that experience has taught us with regard to timing, with regard to what chemical cleaning is effective and when we're wasting our time and those sorts of things.
Okay, great. Marius is up next in the chat, and he has said, how many meters of pipe do you have and how many meters of these will have scaling? I think maybe if you can add as well around tanks as well, how many are on site, etc., and how many are susceptible to scaling?
I'm going to have a stab at this.
Yeah, go with that. This is going to be a good one.
It's a good trivia question, so we'll give it to Mark.
So look, we did in our last plant expansion, which probably gave us about a 30% increase in capacity. I think there was, there's records that show about 200 kilometres of piping associated with that particular upgrade. So that was for a 30 to 40% increase. So it gives you a bit of an idea around the order of magnitude of piping that we have on site, of obviously various sizes. From a vessel perspective, I think we've got about 1,500 vessels on site, typical process vessels. Tanks would be in the order of, I'd suggest 300 to 400 would be my back of the chip bucket estimate. All of them are generally, there's not too many of them that are not subject to some form of scaling.
Okay, great.
Short answer, lots.
Yeah, yeah, I can vouch for that. Haven't been for a look. So Vimlan is in the chat again, and he's asked, are you making use of any chemical scale control, scale inhibition treatment programs?
Limited application for additives, if you like, to prevent scale. One or two tanks on site. I'm just thinking that they're going.
Yep, scale guns.
With mixed results, let's say. Bearing in mind, we're talking about liquors that are already very high ionic strength, very high salinity, and very supersaturated. So the driving force to precipitate is very strong. So any process additive we would use that's not going to be an excessive concentration would need to be very, very selective, very, very effective, if you like. And look, I'm not trying to put a line through that one because it's certainly something that's been kicked around here for a long time, and we're certainly open to anything that's new that's out there. It's a tough one in a lot of our systems to control scale with an additive, but we're open to it.
Okay, great. Will's question has already been answered, so we'll skip Will's. And Jonita has asked, does the solution proposed need to be a product or can it be a process, such as dosing certain chemicals?
I think Daryl might have touched on that one with the additives just now, unless there was anything further from the team.
Yeah, it feels like we
open to all solutions. Yeah.
So Vimlan again, so there could be varying rates of scaling across the unit operations. Do you have any key focus areas for improvement?
Yeah, I'll lean into that one. I'll let the team open it up as well. Was red side part of the operation is a more focus area, I guess, for this conversation. Like I said, it's the in the precipitation part of the plant. That's where we're wanting to essentially promote precipitation out of our solution. The red side part of our plant, just to go back a couple of steps to the Bayer process. What I mean by that is the side of the plant where we're milling, digesting, and then settling the mud out from our supersaturated liquor and associated mud washes in that part of that section. So that's where we do get, I guess, less predictable amounts of scale. At times, it does the operating and maintenance strategies over in that side of the plant are very key to getting predictable outcomes. And we do notice variation in the scale quantities, which can impact cycle times and turnaround times in that part. So yeah, red side is the key area of focus. Open to other, if there's solutions in other parts of the plant, but that's the one of particular interest for this conversation.
Okay, great, thank you. Damaris has asked another one. Will the South32 team give a response to any solution offered or give feedback only to the most promising one? So, I mean, I can answer that one. Generally, we will run through a review process. We'll review every submission that comes through. The response will hopefully be technical and give you guidance, whether positive or negative, on why you have either proceeded or not proceeded through the process. I think aside from that as well, it's worth noting if you're new to mining or if the opportunity you don't quite understand it yet, or you're interested to learn more about the mining industry as a whole, you can always reach out to us at Unearthed via that email exchange that follows this challenge process, and we're more than happy to spend half an hour or an hour of time discussing some of the problem statements that the mining industry might have as well, if that's of value. I will move through. We've got more questions coming in, which is good. How variable is the bauxite feed in terms of silica and bomite concentrations? How do you control liquor chemistry around the hopper surfaces?
Yeah. So yeah, we do have some variation in our bauxite, which we need to respond to as a refinery. Our typical chemistry is around controls around our common processes you'd expect for optimizing for plant yield. So that's your baseline type of controls. But depending on what the feedstock is and our current liquor impurity profile, we'll need to adapt to that. So what we do is we measure the liquor impurities in various key parts of the plant. We have a large part of the Worsley refinery is impurity removal, and those impurity removal facilities are key. So that's from the material that does come in with the bauxite. It's not just the alumina component, and those removal facilities are key for us controlling our liquor impurity concentrations around the refinery and getting predictable outcomes. So yeah, we have a number of those on site.
Okay, no problem. Thank you. Adrian has asked, has there been any systematic thermodynamic and deposition kinetic modeling of precipitation of solutions at different parts of the refinery? Let's answer that one first, if we can, and we'll come back.
Yeah, so the answer to that is yes, for our main products that we precipitate, gibbsite, that's very well understood. For scale and some of the other phases, not so much. So look, it's an area that over the years. And look, Bayer industry globally, grapples with this, and different models tend to be tailored to specific refineries. They can be quite empirical rather than fundamental. So, yeah, look, the answer to that question is not particularly, I would say, with respect to scales. And certainly could be better. Yeah, that's probably a fair summary.
Cool.
We do a number of lab tests around different chemistry conditions and stuff like that. Yeah.
Yeah, correct.
Yeah.
And so, and like even for scales, kinetics is very difficult because, one of the biggest terms, the biggest variables in the kinetic rate equation is surface area. And surface area for scale is variable. Not all scale precipitates as a nice clean sheet. It's an irregular surface. It's dropping out on some of the other solid phases in the slurries, which are then bonding and aggregating. So coming up with fundamental models that actually work is tricky, and any fundamental approach would often need some specific or empirical factor applied, is my experience.
Okay, great. 2 more questions to go as it stands, and then there's a couple more here that I've got ahead of the time. Please feel free to jump in with more if you've got them. Nada has asked, what are the operating temperatures of the pipelines and tanks? And is insulation used at all? Now, I know we covered this in the forum, but yeah, happy to hear that from the room today as well.
Do we want to cover how hot we get?
Okay.
Yeah, so we vary all the way from 175 degrees in through digestion all the way through to white side at around the mid 60s degrees. So it's quite a varied. In red side, where the main of this concern of our current scaling issues are, our main process flow is between 175 and 100 degrees. But we do get down to about 40, 45 degrees in our wash circuit as well, which is also heavily scaling environment. And yes, we do anything with temperatures is generally lags because we do want to recover as much temperature as we can.
Okay, great. Craig has asked, and we might have covered this already, but please add more texture if not. Where in your process is scaling causing the biggest bottlenecks? I know earlier Ash, you said red side, but is there something further to add there?
Yeah, so whereas it's red side, so where we typically focus areas are in the desilication system, the digestion system. Then we go to the settling system. So so that's where we first settle the mud from the supersaturated solution. And the mud washing system. So the associated piping between those, between desilication, digestion, mud settling, and mud washing, that's of interest as well. That's probably the focus areas. Yep.
Okay. No problem. Janita has asked another question, the last one that we've got in the chat currently. So does the solution need to be an existing solution that our company provides, or can it be something novel with R&D in progress?
Yeah, the second one.
Yep, definitely.
So we're certainly open to all inputs, and that's why we went through the process of having the challenge out there. We've got, Daryl mentioned, we've got about 40 years of plant knowledge here, where we're using, methods which are known to us. That's obviously normally caustic cleaning or acid type cleaning or water jetting for scale removal. But that's in terms of the removal side. But if there's other things where we have blind spots or there's other opportunities out there, which we've certainly got an open mind around that.
Yeah, great. Will has asked, and I might add a little bit of extra onto Will's question because it's one that we've had through ahead of time, is how is the existing solution failing in clearing the scale removal process? And I might just add in as well around, is there any visibility that you could add on kind of robotic systems that are being utilized currently on site? We've had a few questions around that ahead of the session.
anyone want to lean in with cleaning systems?
I guess we use RBI, so drones and crawler, sort of like robotic, like remote control cars to run down pipes to detect scale, and then obviously water jetting is our main thing, but obviously to water jet you need to take equipment off, so if we can reduce it I guess at the start and limit downtime, that's obviously a big improvement. And I guess one of the other things which we spoke a lot about, the scale causing flow loss and reducing input or throughput. There's also the safety side of it as well. So we get localized scale, which then creates localized erosion, which then causes equipment to come off, which is even more of a flow loss than the actual restriction in the line. So I guess being able to eliminate that, as well as the major bits of scale, just localized scale as well.
So I think from a removal perspective, in red side, water jetting is an effective solution for removing, the scale. And obviously we've built a lot of our strategies around that. However, there's limits to, it's a very resource intensive process and it's a very time consuming process. So doing that sort of mechanical removal and, particularly, tanks and vessels, yes, but it's more challenging around pipework in particular, just because of the sheer volume of pipework that you've got to deal with. So, that's our current approach, if you like.
And so just to touch on the first part of that question of where our current systems are failing, so we'd resort to water jetting when chemical cleaning is ineffective, if you like. A couple of reasons that might be is that the scaling phase is insoluble in caustic or acid. So, a lot of our red side scales, they're a matrix, if you like, of cementing scaling phases, which might be the gibbsite, might be boehmite, might be DSP, but the aggregate is the mud. And so our bauxite residue are largely iron phases, which are insoluble in caustic. So a lot of scale, if you like, isn't practically caustic cleanable because we just can't attack those caustic soluble phases with a cleaning solution because the mass is just too much of the inert material, if you like. So it's often in that instance where we would need to water jet, or the scaling phase is a boehmite, which is caustic soluble, but just at a very, very slow rate. So again, it's impractical to chemically clean it. It's just too slow, too long. So we would water jet it.
Same with some of our tanks and vessels just aren't viable to chemically clean just due to the sheer volume of chemical it would take to clean that, like acid and stuff like that. You can't put a full tank on acid due to the volume you would require.
Probably the other bit around the robotic side of things, probably the other thing that we do, and again around water jetting, is we have custom rigs that, based on our different types of equipment that, are remotely controlled to make that process as efficient as it can be.
Great. Nadia has another question. Please provide guidance on how potential solutions would be considered cost effective. What quantum of money, and I might add, and support is available for trials?
Depends. I guess all these things that might be, at least are conditional. It's come down to business case, what test work has shown, how promising it is, the scale of it, no pun intended. So it'd be a case by case basis. I don't know that we could put a dollar figure on it. It would be what actually makes sense here, and is there a business case for a trial?
Yeah, so we do have certain areas, from an impact perspective that are probably, create probably more opportunities than a lot of your sort of general scale build up areas and things like that. So there are some niche applications that, have stronger business cases, if that makes sense. And obviously, you try and focus your investment around those particular areas where you get the largest gains.
Okay, great. And then there's a couple more coming in. So James has asked, have you tried ultrasonic cleaning to date?
In small small applications, not on any sort of large scale equipment such as our pipe work and tanks or vessels.
Yeah, so the short answer is no. Very interested if someone's got something to propose, and that's not just around cleaning; it's around prevention. We've seen some things out there that potentially can be applied to heat exchangers around prevention. So, do we do it? Do we use it here? No, is the short answer.
I might, Corey, if you want to jump in, as you've got one more, if you want to.
Yeah, thanks, mate. Guys, just another question about the monitoring side. In terms of detecting things, you mentioned a couple, heat exchange, looking at those types of equations. Have you looked at pump performance before as a way to look at kind of those flows between things that go through, slurry going through pumps, how the pump's performing and if that performance drops off based on kind of inlet or outlet changes, tanks or outlet pipes or things like that?
Yeah, I'll take this one. Yes, certainly do. We're quite active in measuring that and monitoring that on a day by day across the entire refinery. To be quite honest, it's almost a lot of our bread and butter of understanding where our flows are and where our constraints are throughout the refinery on any given day.
Cool. Nice.
We have a lot of online process indication for the refinery to help us understand where those restrictions may be or be occurring. In the absence, if we didn't do that, we got capability to do pump tests and things like that, which might be a little bit more manual. But normally we have the online instrumentation. But in the absence of that, we can still detect where those restrictions are.
Very much so. Yep.
Cool. Nice.
Got another one in the chat. Have you considered laser systems such as surface preparation technology?
I'm not aware of any.
No.
Okay.
No.
That's a really good answer.
Yeah.
Is that with regard to removal, prevention?
It's surface preparation.
Surface prep, okay.
No, the short answer. Or removal, no, Will.
Okay, no problem. Adrian has come through with another one. For deposition in pipes, which size is the main focus? For example, are you looking at pipes larger than 5 inches or smaller than that? What is the approximate pipe length?
Yeah, we run probably, like a lot of our pipe work over on the red side of the plant is, large scale pipe work, typically sort of 500 to 600 mil. For example, we have a lot of smaller diameter pipe work, but 8 inch minimum sort of size. But yeah, a lot of the areas in the piping space relate to that sort of larger pipe work. Would be my position.
Although shine tube heaters, heater tubes are
50 mil, 40 to 50 mil. Yeah.
So it's a lot less, I guess, length, but there's still pain points as heater tubes.
Yeah. So we have the comment that was made earlier around the localized erosion. So from an equipment availability perspective, safety perspective, as Jamie called out, particularly in our piping systems and heat exchangers are no different. We get a lot of scale-induced erosion that that causes problematic failures for us, and availability issues.
Okay, no problem. Thanks so much for that. We've got Brad coming in with another question. Please jump in, Brad, if you want.
Hello. Yeah, just a quick one. How good are you guys at actually predicting scale build up? You mentioned that you're basing your maintenance strategies on time. And is it just, you pull the pipe apart and then you're like, oh, that's how much there was? Or do you have a bit more smarts analytics kind of happening on the scenes to actually move from that time-based maintenance to more like a predictive, it's going to be blocked in 1 month's time type of approach?
I guess from the probably a couple of parts of the question, so I open up to the team after I've let him move it. But we've got our online indication, which might indicate that we've got build up more so beyond our strategy. So whether that's in pressure drop, whether that's in flow instrumentation, whether that's in heat transfer, whether that's in how hard a tank rake is working, to give us the indication of what may be occurring. Obviously, once we've taken equipment offline, the associated, whether it's a tank, it's a vessel, the associated piping as well, we do a lot of inspections during that time to then see what we're expecting and what we got, and then we review that data. I might just throw it back out to the team for further comments.
Yeah, so probably the comment earlier is maybe we do certain piping streams. Again, we've got large volumes, so we don't do it exclusively. Again, we rely on time-based in a lot of cases, but we'll do those internal piping inspections around problematic areas to really understand the magnitude of the scale, how quickly it's building up and where it's likely to have been originated from. The other thing that we're doing in probably more recent times is we're doing a lot of, probably over the past few years, we've done a lot of drone inspections of our tanks in particular. More recently, our vessels, but as part of that, probably over the past 12 months, we've also started using LiDAR systems to get point cloud data around, around the levels of scale. We're probably not using that as effectively as we could be at this point in time, but we're starting to build up data in that space as well.
Okay, and then do you kind of improve on your time-based strategies using that condition monitoring data as well?
Yeah, most certainly. That's one of the big precursors to us, understanding how effective, some of the changes, be it chemistry or mechanical changes are. So, we'll use some of that drone inspection information to test whether we can extend campaign lives and things like that, or in some instances potentially go the other way as well, because there is variability in the rates at which scale forms in different pieces of equipment. So we need to build campaign lengths that provide plant stability, but still as optimized as they can be from an overall cost of ownership perspective.
But generally, those inspections, it's the online plant data combined with the inspections we see during turnaround.
Yep.
That will then inform strategy. I think Brad's with the question might have been a comment around predictive measures for that. Yeah. It's really that cycle, a feedback cycle as we go through that each campaign, where we pivot and then adjust, which we do. That's basically our current process.
Okay, thanks. Sorry, maybe just one more quickly. And then the rate of scale of build up, assuming everything is steady state 24/7, does that seem to be constant, or does that vary as well?
Yeah, we do get variation in it. So one thing is why it's a point of interest for us is because we do have to pivot our strategies to make sure we do get predictable outcomes, and so it is something. So in terms of feedstock, it might be slight variations in the bauxite properties. There might be other factors. Typically, the scales we see are known to us. It's probably more the amount can vary depending on the situation and the cycle that equipment's had. So there is some interest in knowing if we are getting a stronger variation than we'd expect. In the system.
All right, thank you. Cheers.
Corey, do you want to ask? I think you've got another one here. Do you want to jump on?
Yeah, thanks, guys. I think just jumping off kind of what Brad was saying as well, with the inspection stuff, that LiDAR stuff sounds really, really cool. Do you have any other data sets built up, and kind of over how long have you been capturing, I guess, some of the results of scale build up? Like, is there a really good history in CMMS about the thickness and location to some degree that then we could learn from on a larger scale? Like, over how many years has this been tracked, really closely?
I think we're very good with having a library of scale samples of what the composition of the scale samples are in terms of mass and build up in individual equipment duties. I might refer to Mark and team, but I'd say there's probably more intense focus on that in recent times. I wouldn't say we have a comprehensive library of what that is over time.
So once again, even that part of the process is resource intensive. So we deploy it selectively depending on where we see the longer term benefits and where that knowledge is going to sort of help us improve. So I'd suggest we've probably been doing it over the past couple of years around video footage and gaining that sort of image based information. The LiDAR conversation is probably a more recent one that we've only started doing probably in the past 12 months, if I'm honest. So.
Yeah, cool. So you'd be open to potentially looking at things where, you know, someone has a bit of a wider look at, you know, 2 years worth of process parameters, 2 years worth of conmon, 2 years worth of, you know, pickup of that, and things like, you know, if you could know more about, you know, rates of scale build up based on certain parameters, or which parameters are the important ones, or things like that. Are those things that are interesting?
Yes.
Yeah, anything that helps us getting predictable outcomes are an interest for. Yeah.
Cool. Thanks.
Right. Just in the interest of time, I do love the suggestion, Will, around biological agents. Has there been anything to date in that space from the team? Does feel a bit blue sky, as you've called out, but potentially.
Remember, it's hot caustic we're talking about. So pH greater than 14. If you can find a biology that can live under those conditions, you're doing well.
Yeah. Maybe volcanic. But
Yeah.
James has asked, and just aware of time here as we're coming close, if there's any that are left over, we can add them for a response and put them in the forum. So from James, what sort of flow velocities do you have in pipes? Do you induce any deliberate swirling inside the pipes?
Deliberate swirling inside the pipe to mitigate scale. We keep minimum line velocities to keep our slurries from settling out. And so we do have our minimum line velocities in regard to that. But I wouldn't say we have a deliberate swirling strategy around trying to reduce scale or build up within those pipes.
Yeah. So line velocities of the order of a few meters per second.
1 to 3.
For slurries, we can have laminar flow versus turbulent. I don't know that we focus too much on making it turbulent.
Not necessarily.
So, you know, certainly in sections of line, but it's solids free, it's irrelevant, you know. But line velocities, it's of that order that we're talking, a few meters per second.
Typically 1 to 3.
Okay, thanks, guys. We've got 2 questions left and 2 minutes, so let's go quick fire. So, will downtime for pipe cleaning still be an option going forward? I would imagine.
I can't. Yes, I do believe it will be.
Yeah,
is a short answer. Yeah, we definitely wouldn't rule out that at all.
And then finally for this session, and please add any more in if there's any more in the room. Jose has asked, do you have any specific area where would you would suggest that scale formation should be prevented before desilication or after desilication? I think we might have answered that, but
before heaters, I would say.
Yeah, I think that's, yeah. Okay, guys. Well, thanks so much for the session. That was really good. Filled up the time nicely with lots of different questions. I think just before we go, I'd like to say thank you for everyone's time, especially those on site as well, and organising this and the trial run-throughs that we did to make sure that it would all go live today. And appreciate all the efforts from I32 and the Worsley team. So thank you for that. And yeah, thank you to all of those involved. If you've got any further questions, please feel free to email me or Alex, anyone else at the Unearthed team. And thank you for your time today, and I hope it was of value.
Awesome. Thanks, Jack. Thanks, guys.
No worries. Chat.
Thanks all.
Thank you all.
Thanks, everyone. Cheers.